I also wasn't warned that I was going to have to follow Mitch. So, you know, I have to remember that next time. So this session is going to be a little bit different than some of the others that we've done. It's going to be less of a discussion up here as a general rule, and we welcome your questions, because if you stop answering questions, we're done and I can go to the airport. So anyway, as I said, my name is Martin Rowe. I'm the Senior Technical Editor at EE World. I've been in the media business for 32 years. Most of that was with a publication called Test and Measurement World, so that's really where my background is. Then the last few years at EE World, I started up a website, kind of a child website for EE World called 5G Technology World, where I had to learn a lot about the networks that all of you know a lot more about than I do. Up until that time, I thought that 5G was just a radio. And I had to learn a lot in a very short time, but it was a good experience. So this session is called Keeping the Lights On, New Approaches to Efficiency and Affordability. And you notice that it does not talk about, well, it does talk about affordability. We're not going to talk about what we in much of the technical press would call a dirty little word, monetizing. So we're not going to speak too much about that. We're really going to talk about the technology and what it's going to take to do all of the things that everyone else has talked about for the last 2 days. So what we're going to do first is I'm going to ask each of our panelists to introduce themselves. Then I'm going to sort of start the discussion, and that is going to lead into a few slides. And then we'll pretty much open the floor to questions from there. We have a few things that we can discuss as well that I have in mind. But if there's anything else that anyone, feel free to ask questions pretty much at any time. So I'm going to ask our panelists to introduce themselves.
First?
Okay, yeah, I think so. Okay, I'm Young-Han Nam from Samsung Research America. Thanks for having me here. I'm leading 6G system research over there. And to address these capacity challenges in 6G, we believe these spectrum aspects are the most important, especially about utilizing underutilized resources in FR2 and utilizing emerging resources in FR3. So for FR2 side, I understand there are a lot of challenges right now. We don't have enough coverage there, and the ROI, return on investment, is not much. But going forward, I think there have been a lot of improvement along that aspect among different vendors. And in 6G, we expect that there will be even more enhancements there. So we basically try to reach the EIRP, which is like mandated by, we try to reach the EIRP regulated by FCC. So we are currently like a 10 dB behind. And also in uplink side, there could be technologies that can greatly improve multi-user coverage in terms of meeting, supplying like a data rate for different users, utilizing technology called joint phase time array. So that's about FR2. And FR3, that's a newly emerging band, and that offers interesting trade-off. So we can have a very good spectral efficiency with utilizing so many antennas. We can pack within similar form factor as a FR1 antenna panel. And we can also innovate in technologies to give better coverage. And having so many antennas there, so we believe there are some technological innovation need to be made, and that challenge we didn't have before. So basically, together with this AI revolution happening in other industries, so we probably need to incorporate AI from the day one, and we probably need to address coverage and capacity challenges in FR3 in that way. So that's our current vision. Thank you very much.
Hi, good afternoon, everyone, or good evening, everyone. My name is Narottam Saxena. I'm with US Cellular. US Cellular is the fourth largest carrier in the United States, serving in 21 states. At US Cellular, my responsibility is for technology strategy and architecture for both the wireless networks as well as the IT backend systems. Glad to be here. Thank you for the opportunity and looking forward to the discussion today.
Okay, my name is Wanxi Chen. I'm currently 3PP RAM Primary Chair. Really good to be here to see a lot of old friends and meet some new friends. Really pleasure here. Maybe just a few words about this 6G now in 3PP. I think it's all been discussed by quite a few folks before this. Just to maybe to repeat a few information to give you a high-level picture of what's been done so far in 3PP. So far, we have talked quite a bit about 6G timeline and how we're going to prepare to have a 6G study and all 6G work items. So essentially, we're now in release 19. This is the last release dedicated to 5G Advanced. But beginning from next year, in particular next March, we're going to have the first 6G workshop, which will be in Incheon Airport, actually. You're definitely welcome to join for the first 6G workshop. And we'll have the study on 6G. First, we have something called the planner level study. It's basically to look at the requirements, use cases, whatnot. And these will be the one to have a high-level understanding what 6G can bring values to the entire community. They're also going to provide good guidance for another study, which is called a working group study. That will look at the details, particular techniques to enable these kind of requirements, to meet the requirements and the user cases. So the run level study, we're going to have two phases. One phase is try to have a new study already approved in December this year. This is try to connect somehow with ITOR study, particularly talking about these TPRs, technical performance requirements. This will be the first step, if you will. And then we're going to have another study, which is more like a general study, which will be approved right after the workshop in March. So that's the RAM planner study. The working group level study will be approved in next June. This will be a study for 21 months. So it's starting from June, lasting 21 months. So these will be, as I said, will be the one for all the working groups. You know, it's particularly we have this round 1 physical layer, round 2 mecha and high layers, round 3 all these internet networking and round 4 performance requirements. So all the different working groups will be involved in this study, and this is going to be something very important for us to understand better the potential techniques. Will be the foundation for the subsequent so-called work item or specification work in RIS 21. So that's the plan for now. And for RIS 21, that's still something we still need to discuss, timeline. Part of the reason I think is also being brought up by a few panelists earlier. There's definitely some doubts about what 6G can bring, what kind of values we could have from 6G, and what 5G can do that 6G, let's say what 6G can enable some new aspects. So this is part of study. That's something we need to prove. That will be the one. The study will drive how we're going to determine the timeline for the RIS 21 for 6G specifications. So that is something very important for all of us to do, to show that 6G really can bring good values, not just from traditional KPIs such as throughput, but also from many other aspects, energy efficiency, coverage, all the different specs. I personally have a very high expectation for it. I also think it's very promising. Okay, that's it. Thank you.
Hello, my name is Masa Kawashima. I work for NTT, a Japanese telecom company, as the ION technology director. Some of you may not know ION. ION stands for Innovative Optical and Wireless Network. I'm going to explain the concept of ION in this session. And also, I'm serving as the Technology Working Group Chair of the ION Global Forum, which is a global organization to develop ION technologies. And I'm basically a system architect. And the topic of this workshop is to find a new use cases of 6G. But if we want to create new values with new user experience, just upgrading radio network is not good enough. We have to re-architect computing architecture and also the optical transport network architecture to make a really new user experience. This is one of the initiatives I'm leading in my company and also in ION Global Forum.
Okay, so as part of my work at EE World, I cover a little more than the wireless part of networks. I also look into the wired part, the optical part. And as a result of that, I attended about 6 months ago the OFC conference, which is the optical fiber people. They are the people who have to take all of this data that is coming wired or wireless and get it to where it needs to go. And there was a bit of I'll call it a concern that everybody had. And I had never seen this before. And they were all worried about AI. Not AI itself, but from everybody using AI to, whether it's for whatever reason, and all of the data and all of the machine learning data, I think especially the machine learning data, how are we going to keep up with all of this data that we are assuming is going to come down the network? And because as a general rule, the data rates on optical networks double about every 2 years. And 2 years, 3 years, something like that. Right now, data centers are moving from 400G to 800G. That means gigabits per second. Nothing to do with wireless, in case. So they're really worried about this. There is starting to get some talk about 1.6T, 1.6 terabits. I think it was Keysight did a kind of proof of concept demo at OFC, and I also saw just within the last few days that Viavi had announced a tester for 1.6T, which means Keysight's got theirs in the works too. And they were also talking about, okay, when are we gonna have 1.6T? When are we gonna have 3.2T? One person even said, this is when we're gonna need 6.4T. So they're all a little kind of concerned about that. And one of the things that they talked about was, aside from this data having to, how are we going to keep up? And they don't know. So I'm hoping that if there's anybody here that would like to add a few words to that, you're free to do so at any time. But what I wanted to move to now is, we're also going to talk about some other things as well. But what I wanted to move to now was to Mahasia's presentation about ION.
But before that, maybe I'm going to answer to that question.
Okay, well, you go right ahead.
And transceiver. Mm-hmm. So that's a good question. So basically, with LLM, the size of AI model grows 10 to 20 times about per year. On the other hand, the packet switch capacity and transceiver speed only doubles every 2 years. So that means we would keep adding packet switches, and we would keep replacing transceivers with the upgrade. We would keep upgrading transceivers. So that's going to cause the kind of infrastructure cost explosion. So this is one of the issues that we are trying to solve with ION All Photonics Network. So ION All Photonics Network aims to make the infrastructure bandwidth free or bit per second free. But if we could eliminate packet switches and transceivers inside the infrastructure, we would be able to upgrade the connection speed just by replacing the transceiver at both ends, at customer-side transceivers. We don't have to upgrade the packet switching node or transceivers inside the infrastructure. That means the infrastructure will be bandwidth free or bit per second free. This is the objective we are trying to achieve with ION APN, and this will solve the issues with data explosion issues. So this is one example of ION Global Forum's innovation.
Okay, do we have the slides? I think we've got 4 slides.
Okay, so following up, let me explain what we are trying to solve with ION APN related to O-RAN deployment. I think we should be aware of the gap between 5G's C-RAN or O-RAN's beautiful concept. I mean, radio access network should be cloud native versus today's actual O-RAN deployment, which is far from being cloud native. To me, what I expect from cloud-based architecture is elasticity and agility. Elasticity means we being able to dynamically assign processor resources in accordance with traffic variation. Also, agility means being able to deploy radio antennas in responsive to user demands. I believe these 2 important points are very important for future radio access networks because mobile networks are varying and unpredictable. And also, we would like to use millimeter radio. So in order to leverage such bandwidth, the antenna deployment should be changed from macro cell practice to more small cell practice. So antenna deployment should be like deploying public Wi-Fi antennas. In order to address these issues, today's computing and network infrastructure are not good enough. Today's computing and network infrastructure are basically designed for web applications. They cannot handle the data processing and data forwarding in a jitter-free way. So we have to upgrade transport network and also computing platform to make radio access network that is really cloud native. This is what we are trying to achieve with ION APN and ION's computing platform. So please go to, so I have to use this. So let me explain ION's APN and ION's disaggregated computing infrastructure called DCI. So as you see in the next slide, today, front haul network is it relies on physical cabling, and the computing resources is statically assigned with today's computing platform. But what ION APN is basically a circuit switched network using wavelength selective switching. So this will allow us to create a front haul as a logical connection. And ION's DCI is a disaggregated computing platform that will dynamically allow us to assign dynamically processor resources to the front haul. So with that, basically, we can make a cloud elastic computing, elastic infrastructure. And one of the benefits we can expect from ION APN is related to affordability of mobile service. So many carriers are now struggling with heavy capex of base stations. So many carriers would have to share radio towers and front haul infrastructures to make new services, next generation services affordable. And because ION APN is a circuit switch network that allows multiple mobile network operators to share the radio towers and also the front haul infrastructure, we can allow mobile network operators to deploy radio antennas in a cost-efficient way. And also, the deployment of radio antennas will be much more agile because we don't have to wait for the delivery of dark fibers. Instead, we can expect carriers to create logical connections between radio antennas and mobile operators' radio DC. And another important benefit from ION's APN and DCI is related to energy efficiency. So in today's O-RAN deployment, basically computers are statically assigned to front hauls. But with ION DCI, we can dynamically reconfigure the association between radio antennas and DU host. So that means maybe, for example, in daytime, we should put we should make more antennas on the business districts active, while we can put antennas in residential areas at sleep mode. But when in nighttime, we would like to make more antennas in business district sleep mode, and we would like to activate many more antennas in residential areas. And in accordance with that antenna operation, we can dynamically reassign processor resources in DU host, so we can so that the total size of a resource pool can be reduced. So this is related to energy efficiency, and also this is related to the capex for DU host infrastructure. So this is one of the examples how the upgrade of underlying optical transport network and cloud computing platform can contribute to the evolution of radio access network. That is my explanation about our activity.
So you're talking about moving resources, say, from daytime to nighttime.
Yeah.
When you say resources, you're talking about computing resources?
Yes, basically CPU, computing processors, and when the accelerators are used for the front haul signal processing, then we would also have to reassign accelerator resources as well.
I see. Are there any questions from the audience about this concept?
David.
So yeah, a question, I guess. Does the optical network have to be part of the same administrative domain as the wireless carrier, or is there an opportunity for those to be separate entities?
That's a good question. So, for example, in Japan, we have 4 mobile network operators. If 4 mobile network operators deploy such optical transport separately, that would be a huge cost. So our intention is to allow regional carriers like NTT East and West build such optical transport network and provide a circuit switch service to mobile network operators.
So a follow-up on that question is that, okay, NTT offered all infrastructure APN, and now you say you have 4 operators over there. So how do they guarantee that they will be treated fairly, evenly?
Here?
Fair, just equally.
There are a lot of competition rules that will, even today, for example, NTT East and West provide optical transport network, and we use that service for many internet service providers' business. So there are many very strict competition rules so that NTT does not leverage that position. So it's a kind of business rule issue, and of course, basically we will provide this service in a very fair way. And also, I'd like to point that it doesn't mean that KDDI and the carriers should not provide APN services. They can also provide APN services. So in Japan, we are now running a national funded research project to build a multi-operator or photonics network so that APN can grow like internet. Internet grows as a multi-domain network. And likewise, APN will be a multi-domain optical network. For example, data center providers will build their own APN. And carriers will provide our APN. And these APNs will be interconnected to form large-scale optical transport network. Thank you very much.
Is there anyone from a carrier who might want to comment on this?
I can ask the question.
Thank you.
So, my understanding is Japan has a lot of fiber penetration already, right? I mean, it's pretty dense, and its households are covered are pretty good. How does APN fit into that play? Are you competing with the fiber provider, or are you going to be a separate provider of the APN to other segments of the business?
So in Japan, basically, NTT East has fiber. So in Japan, we are a service operator and also a fiber carrier. So we don't compete with fiber carriers. But for other areas, typically we have local fiber carriers and we have telcos. In such cases, telcos may build their own, build their APN, procuring fibers from local fiber carriers. So they won't be a competition. Actually, the local fiber carriers and APN service providers would be a complementary relationship.
Thank you.
So, Martin?
Yes.
So based on this new architecture over here, of course, if you want to guarantee the future success, you also need to interoperate with all the wireless network on that part, right? So Wanxi, the question to you is, now when we have introduced this non-terrestrial network into the terrestrial network domain, so do we also need to maybe start looking into what ION can do for 3GPP if that has not been done?
Regarding NTN, you mean?
Just like, no, I'm talking about the standard side, okay?
I see.
Now you have this optical network over there, which is not fitting into the conventional wireless structure. But Wanxi, like
Yeah,
in 3GPP, we focus on that one. So do you foresee something like that, or it's been doing?
That's a good question. Of course, we need to collaborate with many standardization organizations. So I think, I'm not sure whether the 3GPP would be the right organization. At least, for example, we believe, we see that we have to work with ORAN, because ORAN is about implementation, and the scope of ORAN includes transport. So ION Global Forum will collaborate with ORAN so that ION APN-based ORAN implementation is is recognized as one of implementation options.
Okay, so
I'm not sure about the scope of 3GPs. Does the scope include optical transport.
I don't think so, actually, at this
It
point.
is,
I think at least not clear to me how this is going to interact with CPP. At this point, I don't see any interaction per se from certain perspective. If anything, it probably can be done in different standard bodies and eventually just implementation somehow. But this is, as I said, is something new to me. It's hard to evaluate at this point.
But on the other hand, we see that we have to work with ITUT SG13. They are discussing the architecture of the infrastructure. So we would work with ITUT SG13.
Because I think this will keep you guys busy for a while because we already have so many things on the plate, right? So if you all of a sudden you also want to get ORAN somehow in the picture, right? The kind of competitive matter. What do you think?
You talking about how ORAN going to be interact with CGP? Or? I mean, this is ORAN versus CGP is always a very interesting topic. It's to some extent also very sensitive. I would say that ORAN has done quite a lot of work in the past, and also now been actually actively doing a lot of things to do evolutions. I think for 6G is also important topic for us to discuss, particularly how 3PP and ORAN should work more closely together. There are few things that may need special attention. For example, AI machine learning, I think is one of these important aspects that may cause some kind of overlapping or even conflicts if we do not step in to take some actions. So at a certain point, I think we need to have these two standard bodies. Of course, we have this official liaison or whatnot that can already have communications, but we may need to even think about what we can do more. I think the most important thing to me is how to see the split of work between these two places. I don't see the strong need to move the work in ORAN to CPP. I don't think it's necessary, and even if you move that, it may not be beneficial actually to the entire community. So it's probably good to have such a split, and the important thing to make sure the split is clear, and also to somehow have both sides to recognize that there's other, like CPP to recognize as ORAN, and somehow maybe there could be even some references in CPP to the ORAN document somehow. And also, I also wondering at a certain point maybe there could be some need to have maybe some general workshop between the two bodies to understand each other better. But in any case, I think 6G is important to have these two sides to work more closely than before.
I would agree with that because I think one thing to avoid probably is multiple splits that was created when ORAN was formed, when 3GPP created and handed off to ORAN, and now we ended up with 4 different options, right? Now proof's in the pudding because all the vendors have to either support all the 4, and if they don't, the interoperability breaks. So it's very important to have that coordination between the groups.
I think so far, this 3GPP and ORAN, they were kind of coordinating relatively well on this frontal aspect. 3GPP has defined some high-level requirement, and ORAN executed a lot of details on top of that. So probably similar type of collaboration will happen in 6G. That's our hope and expectation. And going back to your question, I had some offline discussion with Kawashima-san before this session, and I was trying to figure out what could be ORAN impact. And my current impression was that we can reuse the existing frontal spec without changing anything to operate ION at the moment. But there could be some improvement we can do that's probably for future standardization people's work.
Basically, our work is just one implementation option of ORAN. So there's no conflict between today's ORAN specification.
Okay, any other questions before we move on? No? Okay. I wanted to talk a little bit about energy efficiency. There hasn't been that much talk about it here, nor last year. 2 years ago, I don't remember if it was here or it was at the Brooklyn Summit, there was a presentation that talked about how energy efficiency has to be almost at the top of 6G. And it seems to have faded to a small part of the discussion in favor of business use cases and so on. But what I wanted to bring about is there was also a comment made earlier today, where someone said, and I'm paraphrasing a little bit, but is there any app on my phone that I need 5G for, or that I can't, that I could also do just as well on 4G? And I pick up my phone here. I have 2 5G phones in my pockets. Both of them have 5G turned off because there is no app that I need 5G for, and by running it at 4G or LTE, I can do the same thing and use a little bit less energy. And I actually ran some experiments on this on my phone, and see what would happen. And sure enough, I've published the data just to see that there's no need to keep it on. So what are we going to do about this? And then we could look at this from the entire range, from the radio to the network to the chips to the power supplies. What can we do about that? And I wonder if our panelists have anything that they'd like to say about that.
I can start. This is a very good question. First of all, Martin, I'm not sure how you get the impression energy efficiency for 6G is going down. I don't see.
Well, I guess we may need to find an app that will require 6G.
But let me
after we find one that requires 5G.
Yeah, but let me put this way. I do believe energy efficiency is one of the core part for 6G. I think it's very important. Let me give you a little bit background on what has been done so far in 5G. Of course, we already have a lot of knobs in 5G, even in the first release, to emphasize energy efficiency, but it's mostly on the UE side. Then later on, there's also a lot of study and a lot of real data to show that the 5G base station probably consume more energy than 4G. The primary reason is because 5G base station, you have 100 megahertz, and 4G, you have 20 megahertz. And if you look at the energy efficiency per bit, 5G is still better. But if you look at the operators, they will say, we don't care much. What we care is the per base station cost. The energy cost is higher just because the bandwidth is 5 times higher. So that's something also drives us to work on this network side energy efficiency, which we already done this in RIS 18, and now continue doing this in RIS 19. On the UE side, there's also a lot of evolutions, even starting from the first 5 release. We're doing a lot of things to see how we can improve the carrier aggregation, because carrier aggregation is one of the most important technical enablers to give a high throughput. But at the same time, it's also not friendly to power consumption. And we're also doing a lot of things on how to look at so-called control channel, because a lot of time UE is in idle, or let's say in inactive state, or at least in idle in terms of traffic perspective. And in that case, you have to spend a lot of time on monitoring the control channels, how we could reduce the energy consumption for control channel monitoring. This is something we've done quite a bit also in the standard. Most recently, we have been working on this so-called low power walls, wake up a signal or wake up a receiver. This is more like to enable the UE side to have a very low cost, extremely low power to monitor some signals. And then at a certain point, you can also activate so-called main radio to have both power consumption at the same time, to have a good being responsive somehow to reduce latency somehow. So this is a lot of things being done. But of course, when it comes to implementation, there's maybe in your phone, the implementation not there yet. So the fact that all these things being done in different releases and also in a way, done separately for network and UE side. And now even on network side, when we try to further improve the energy efficiency for the base stations, there's also some limitation we found, just because you don't want to change the base station design such that they're gonna impact the legacy UEs. So there's certain limitations. So all these things, I do believe this is a lesson we learned, and I do believe all these things will be somehow reflected in the 6G from day one. So basically, we should try to improve energy efficiency on both the network side and UE side. And just imagine later on, if you have a 6G phone, you can have a phone, even if active usage per day, you still have 50% left. That's quite ensuring to me. I think that could be one of KPIs that we can emphasize for 6G.
I would agree with you. I mean, I think on the base station side, in the last release, I mean, we did the receive transmit port adaptation that brought the base station power energy efficiencies gains higher actually. And I think that's one area where we have saved. And I think you're probably not hearing it, what you heard 2 years earlier than now, is because a lot of progress has been made since then, right? A lot of like energy efficiency is happening today, even in the current networks, where you go into sleep mode. 2 years ago, if you go back, you started with micro sleep, then you went to massive MIMO sleep, and now you're going further to the automated energy saving mechanisms. So you're shutting off the network in off-peak hours, at least some components of it, so that you can get some energy savings. So I think a lot of steps have happened, but it has not gone away. It is still at the top of the list, even for 6G.
Well, that's what you get when I work in media, you tend to focus on the things that you hear a lot about. And work goes on in many things that we don't often hear about. But so thank you for that. The other efficiency was spectral efficiency. Oh, I'm sorry. Go ahead.
By the way, do you have any comment regarding energy efficiency?
Okay, yeah, I have a couple of
I'm
comments.
sorry. We'll go right ahead.
Okay, so I think Wanshi covered very well about 3GPP standardization aspects. And in 6G, probably, I mean, as always, as we increase our generation number, we will have a better spectral efficiency. And spectral efficiency is directly connected to energy efficiency. So basically, if we spend less time for transmitting same amount of data, then we can turn off even more. So basically, in 6G, I expect we are going to have a better spectral efficiency in that aspect, along with all other mechanisms Wanshi was talking about. And in implementation point of view, there are new technologies emerging, for example, symbol power tracking. So in OFDM, the signals are not actually uniform power in time domain, and that incurs a lot of inefficiency right now. But we could track this symbol power across the time domain, and we could change bias voltage so that we reduce dynamically power consumption. That's a kind of another emerging technology being discussed in industry. So I think combining all these together in 6G, we will see greater energy efficiency from both network and UE side.
I'd like to say there are a lot of things that we can do to reduce the power consumption of a radio access network. And I often discuss many ideas with my colleagues in NTT Group. But some people ask me, why? Because even if we reduce the energy consumption, basically, we would have to buy radio base stations. So basically, the CapEx won't change. So what's the real benefit for mobile network operators? So many people will say that energy consumption or energy efficiency is very important, but it's a kind of a diplomatic phrase. Actually, they're concerned about the CapEx of radio base stations. So for example, please imagine one base station is very simple, and they keep consuming energy constantly. And then there is another intelligent, expensive radio base station that reduces the energy consumption very intelligently. So which radio base station would sell well? I think that the answer is very simple. So that's the real situation. So the issue of energy efficiency is we have to find a solution that can reduce the energy and also the operator's expense. That's the real issue. And also, I'd like to point out, there are some lack of technology standard for elastic operation of radio base station. For example, when we shut down the radio base station, somehow we have to define a process of graceful shutdown of radio base station. And such industry agreement has not yet been defined. So that's another issue for energy efficiency.
It's very interesting to hear your views. Yeah, I mean, the cost of doing this is definitely very important. I think at the same time, it's also important to realize you have different type of base stations.
Yeah.
You have micro base stations, you have small base stations. If you do this drastic change of, let's say, shut down the small cells, it probably had very minimal impact, but you have a micro cell, you may have to do some advanced, this wilting and blossoming, whatever process to have slow power ramp down, slow power ramp up, different things. But even with that, I think there's still quite some room to do better.
Yes, yes.
One of the things that I also cover is power electronics, and so I go to a show for that every year. And as just to kind of to say what Narottam said is that yes, there is a lot going on, and on the power electronics side, there is a lot of work, particularly with with silicon carbide, gallium nitride in the power supplies. You can see it even in just walking around a show floor and seeing the phone chargers that will be on display. And I have an old iPad charger, and it puts out 10 watts. Well, now you can get 20 watts and half the size and half the and twice the efficiency. So even in that, so even just in the power supplies, there is an improvement, and that is a very important thing to them. So you'll see that, I think, coming. And that's one of the things that will not get discussed here. But it's one of the things that would affect your bottom line.
Yeah, of course.
Absolutely. All right, so spectral efficiency. What can we do about that in terms of, I mean, it's been talked about a bit here already, but there's been talk about different modulations. Someone, I didn't get to see it, but someone had a session about a week ago. Do we need a new waveform? Unfortunately, I haven't had a chance to watch it yet because I was preparing for this. So what can we do, what can engineers do in terms of improving spectral efficiency? Yes, we all need spectrum, and I'm not talking about getting more spectrum. I'm talking about, and maybe not even about spectrum sharing, which is that's a whole other thing that we get into. But in terms of, the radios themselves, is there anything we can do, or is that too tied to standards because we have 5G NR and we're kind of stuck with it until another standard comes out? Is there anything we can do in the interim?
So who wants to start? I can start. I think there's still quite something we could do. Even look at the current 5G. If you recall what happened from 4G to 5G. In 4G, we have this something called the common reference signal. This is more like always on signal, which is also provide a lot of benefits in terms of better channel estimation, measurement, mobility, all the kind of different handling. But at the same time, it causes issues: interference, the energy consumption, and of course the spectral efficiency. So that all the things being addressed now in 5G, we have let's say less always on signals, but still with 5 milliseconds, this kind of periodicity to provide a good trade-off between GNB and UE implementation complexity. At the same time, there's also control channels, all different things. I think the key thing, I think, is that for all these kind of cases, there are certain rooms still for us to further optimize. For example, even for the so-called sync channel, the six signals, the control channel, how you could do things, even for channel estimation. For all these so-called DMS, they call demodulation reference signals. You could place your DMS in some better locations, maybe. So there's certain things we can still do. But of course, there's easy ones, which you already asked not to comment, like new spectrum, all the kind of things. But I would say the new spectrum, if you look at FR3, is also offers us a good opportunity to see how MIMO can be better designed. Because in that case, you could definitely, in the same size, you can squeeze in more antennas, and how to do better beamforming. How this is not just starting from initial channel or the data channel. You can do a lot of things to see how you can do better management, not just from the beamforming gain perspective, also from robustness, everything. So I do believe there's still quite room for enhancement. But this is just pure physical stuff. But if you look at probably even more important, in my opinion at least, is that in some cases you may have some spectrum which may not be wide enough, especially in the lower carrier frequency. You could do the traditional carrier gauging somehow, but each carrier, if you do carrier gauging, each carrier is by itself. It's more like standalone carrier, and then you have to carry a lot of signals somehow. But can we do better even in the carrier gauging context, or maybe do something to take a new look at all this fragmented spectrum to see what we could do better? For example, maybe the spectrum, even if that not completely contiguous, maybe they can be somehow aggregate into a single carrier from UE perspective. And then you can do better in that sense. You can omit the transmission of some overhead signals. At the same time, of course, hopefully there's also good advance in energy efficiency, all the kind of design, so that UE can utilize all these different fragments of the spectrum into a single one, at the same time not cost too much additional energy consumption. So that, to sum up, I do believe there's many areas we can do better in 6G.
So FR3 kind of offers us an opportunity to do
Yeah.
5GNR 2.0 or 6GNR, as the case may be.
Well, I would just comment on FR3. I think you covered extremely well on all the things that 3GPP is doing and some of the ideas there. But on FR3, it's a broad range of frequencies, right? It is sitting between FR1 and FR2, 7 to 24 gigahertz. I think when you go to 7 gigahertz, you can probably match the grid of 3.5 gigahertz with packing more antennas and keeping the same aperture size as you mentioned. And then I think that would be very helpful when we deploy. But as you go up in the frequencies, that may not be the case, because then your coverage is going to shrink. You have to build more cell sites. So I would say FR3 in the context of between 7 and 13 gigahertz is good. Anything above 13 gigahertz is a different ballgame.
Yeah, so continuing this discussion, in 3GPP release 19, we are trying to support 128 CSIRS ports. So that's actually going to be like an interim solution to get better spectral efficiency in 5.5, we call 5.5G. So basically having double the number of antennas typically implemented in industry right now, that's 64. In 5.5G massive MIMO solution, we could have 128 antennas at a 6 gigahertz carrier frequency that was newly approved by WRC 23. So that could be one way of improving spectral efficiency, but not full extent. So in 6G, we can have many more innovations, especially around AI. So basically, I think I already mentioned it in my introduction, but I think day one feature in 6G is going to be AI CSI compression, for example. So currently, we don't have a code book available for 128, 256 antennas. But in 6G, from the beginning, probably we will rely on some AI-based CSI feedback that they will actually offer us a better opportunity for improving spectral efficiency. And also modulation side, currently we are relying on this square modulation waveform constellations, but we could also consider circular shaped modulation constellation that's being already considered in like image processing community. That actually gives us a shaping gain of like 1 dB in certain SNR range. So those are the approaches we can probably consider in 6G to further improve spectral efficiency.
So regarding spectrum, my comment is not about spectrum efficiency, but regarding spectrum sharing, I think there are a lot of approaches that we can consider, and dynamic spectrum sharing is a kind of extreme concept. But for example, in Japan, I think we can consider a type, what I call micro licensing. Today in Japan, for example, basically the spectrum is assigned to a mobile network operator on the same spectrum is assigned. When the spectrum is licensed, that license is applied to the entire country, entire nation land. But maybe we can consider the licensing per region. Actually, even in Japan, there is some exception. In Tokai area, some bandwidths are assigned to one mobile network operator, and in another area, the same bandwidths are assigned to another operator. So there's such practice already, but we can consider the land and also the time that the license is defined.
Yeah, I mean, if you talk about spectrum sharing, I mean, in the United States, it's a little bit different. We do license, I mean, licenses are by PEAs, to your point, PEAs and millimeter wave was counties too. But I think two levels of sharing come in, right? One is sharing of spectrum with a previous generation of technology and next generation of technology, which is multi-rad. And I think 5G to 6G, we should keep that in mind for two reasons. One, 5G was designed to be a lean system than 4G, and you talked about common reference signals overhead. So that should ease us to gradual evolution of 6G and not do a forklift upgrade and necessarily have to go there. You can use the existing spectrum to deploy 6G. The other type of sharing is with many spectrum bands in the United States have incumbents who are sitting there. Incumbents being fixed services, broadcast services, satellite services, DoD, and other areas, right? So the spectrum landscape has changed. While as an operator, I would love to have spectrum, which is high power, exclusive licensed, because that makes the life extremely easy and more effective, more efficient, and you can squeeze every bit out of that. But the spectrum landscape has changed. And while it's important for US, global leadership and economy to license the spectrum, we also have to consider sharing because we have incumbents there. So when it comes to sharing, you probably want to make sure that the incumbents and these other operators who are going to use this, both are open and transparent in sharing information. Because without sharing information, you cannot come up with an efficient form of sharing. Sharing has to be done in time, frequency, or space, or geography domains, right? That's the way you're going to share the spectrum. But when you share the spectrum, if both parties are more open and transparent to each other, then we can come up with mechanisms of saying spectrum can be high power, can be shared 24/7. You don't create exclusion zones. And then you can also, it's very important, paramount to network experience, to share the spectrum in the 3 dimensions: frequency, time, and space.
Okay, another thing that I don't think came up much earlier was coverage. And I'll relate a personal situation where I was in upstate New York and had driven through a state park, and when I came to the other end of the park, I now said, okay, I need to get to the interstate. Of course, I don't have maps anymore. I pull out my phone, and there's no service. I pulled out my work phone, different carrier, no service. So I suddenly had to sort of navigate on my own, knowing that the interstate was somewhere north and hoping that I could find my way back, which I did eventually. But it was one of those things that you know, here was just an area in New York, and there was suddenly nothing. So would anyone like to comment on that?
I can start on this. I think the coverage is definitely one of the most important things also for us in CPP. In the past, if you look at 4G, we start with the release 8 for LTE. Somehow we realized towards almost the end of release 8, we realized, okay, now if you compare the so-called TTI, this 1 millisecond, it's shorter than before, so we had to do some repetition. So the repetition of uplink transmission was done towards the end of release 8. So try to improve the uplink coverage, because uplink typically is the bottleneck for uplink for coverage. Now in moving to 5G, we specified all these repetitions in uplink in day one, but then later on we still found that we needed some additional enhancements, and this was done in quite a few releases already to do all these kind of different message 1, message 3. These are essentially some initial access signals that need to be enhanced. So we've done quite a bit of it. And also, if you recall what happened in the so-called machine-type communications, we have two flavors. One is called Narrowband IoT, the other one called eMTC. Both have some much more expanded coverage. So we're talking about 15 dB, 20 dB coverage compared with the smartphones. So this has been done quite a bit, but I think moving towards 6G, this is something we have to look at the group very carefully. I do believe coverage has to be done in day one. I hope at least in CPP, when we finish the first release of 6G, or say the coverage is done. We don't need to do coverage enhancements in the subsequent releases. It had to be good enough, or not just good enough, had to be better than before. And so that we were, imagine if you have a 6G phone versus a 5G phone, then if you see almost $5, in your phone, when I move anywhere in 6G, even if with let's say compromised data rate, I don't think you need 1 gigabit per second all the time. Imagine you just need 20, 30 megabit per second. Even that, you could still have a very good coverage. I think that'll be very important from a user experience perspective.
Yeah, I agree. I think the uplink enhancements are key for coverage. And also even on the CPE side, right? Like if you have a fixed wireless access kind of CPE, you can pack more antennas. And so that also helps you with the coverage. But then the third one, which is an expensive one, is densification, right? Densification comes at a pretty good price points. So you're not going to see like, so you will see a lot of CRANs, a lot of small cells, cell split, but only to a certain economic point of view, right?
Okay, Wan Xi mentioned about the uplink coverage, and there are actually certain things we can do, only so many things we can do about the uplink coverage. Wan Xi already mentioned about the repetition, but another thing we can do is we improve our MIMO receiver. So basically, MIMO gives us uplink beamforming gain, and that actually, in downlink side, we can always increase the EIRP and so on, but uplink side, we are mainly limited by UE side EIRP. So to increase uplink coverage, we need to have actually more base station antennas, and that actually gives us opportunity to improve uplink coverage. But just having more antennas is not enough, and we actually need a better receiver, and that's probably the next level of innovation we can do with AI/ML.
Okay, we have a few minutes left. Are there any questions? Yes.
For the lack of coverage you are talking about in national parks or the place where you are in, the only way to do it is to put additional cell sites. You see, otherwise the cells over there are 20 kilometers long, I think. That's the reason you can't put, you can repeat 1,000 times, you will not get the coverage, or you can put 20 antennas, you will not get the coverage on the uplink. You have to put additional sites for the scenarios you are talking. Thank you.
No, I agree with you, Amitabh, because in his scenario, you'll have to put a cell site.
I was outside the park and had to drive quite a bit of a distance to get coverage. I was near the park, but not in it. But nevertheless, it just had to.
Same thing in Wyoming, Grand Canyon. There is no coverage, 2G coverage. Or you can do NTN.
Yeah, I think
MTN, yeah.
There we go.
I'd like to remind one thing. So basically, path loss exponent with the line of sight is like 2, right? And if we consider this coverage distance, if we improve 3 dB, then we can get 1.4 times the coverage. That's like a simple math here. So basically, anything contributed to uplink SNR improvement, that will actually really contribute to our coverage improvement. But maybe your scenario is beyond that 1.4x, then there are nothing we can do. But yeah.
And I'd like to add that, so in order to improve the coverage, we need to put more cell sites. So that's why I say that the agility of antenna deployment is very important. So, and also I see that with new generations of radio access network, now it's becoming more difficult to maintain radio quality in urban areas because a lot of buildings are causing a lot of radio interference. And so one of the issues is how to maintain a radio quality in urban areas. I mean, a very complex structured space. And maybe we can consider using AI technology or digital twin technologies to solve this issue.
Perhaps. One last thing I want to bring up, and we'll keep this short, is let me see if I remember what the acronym stands for. Reconfigurable Intelligent Surfaces. Okay. Now, an hour ago, well, 2 hours ago, I would have said, is there anything at all going on in this area? Lo and behold, I get on my email a press release from a company in Taiwan saying that they had introduced some, so I haven't read it, but some sort of reconfigurable intelligent surface. So I guess there is some work going on there. Does anyone like to comment or know? I know there was a lot of talk about it a few years ago, but I hadn't heard anything until today.
maybe I can share a little bit from CV perspective. We did have quite some interest in release 18, the first release for 5 advanced. Quite a few companies really push hard to have at least have some study, look at channel modeling, inference, whatnot. And then somehow, I think these somehow to me is connected with all these topological enhancements that we had. It's not as simple as sound on paper. So eventually it wasn't included in the release 18 project. And once come to release 19, the interest level dropped a lot. And nowadays in 3GPP, nobody talking about release anymore. So that's the situation. I don't know how this is gonna be reflecting in 6G study, but honestly, I think there's many issues we need to look at for release to make sure it's more mature enough for commercial deployments. But of course, with that said, I think the one in Taiwan is probably some implementation only product. It's not based on anything in the standard yet. For implementation, if you already have something that has been ready to improve, especially in the control environment, I think that's probably can bring some benefits.
Yeah, okay. Anything else?
No, I would agree that our RIS is in early stages, evolving and maturing, but you probably need it. You need it as you go up in the frequencies. Like if you talk about millimeter wave, right? If you want to increase the performance of millimeter wave, you probably need smart repeaters. You need some RIS available so that you can increase the performance and the coverage. So I think it's a matter of time. Hopefully it doesn't die.
Well, I'm hoping to get a live demo in a couple of weeks at the IEEE conference on phased arrays, which will be in Boston. The company is going to be there, so I'm hoping to get to see it in person. Okay, that's going to do it. Thank you, everyone, for staying to the very end. And to everyone, have a good trip home. Thank you.
Thanks.